basics of Python, we get to see that it's got a very friendly syntax. It pretty much codes almost like pseudocode in some ways. And at first, it's going to be a little weird because we're coming from JavaScript, we're coming from this one framework, but we're going to notice some parallels. Have people coded with Python before? Anyone already familiar with the language? Anyone know why it's called Python? Oh, you guys, oh, right, okay. So Alyssa already stole all of my content for this lecture, I guess. Yeah, it's got nothing to do with snakes or with pythons. It's the creators were huge Monty Python fans, and so decided to name their language after that. And actually, the language has had a lot of different Easter eggs scattered throughout to kind of make it kind of a fun community. There's quite a few kind of jokes hidden throughout Python that I think are pretty fun to discover. For example, when you want to import a module, you type in import, and specifically import anti-gravity will open up a new web page to a very popular comic, XKCD, if you guys are familiar with it. As I was preparing for this lecture, I found this Easter egg and basically wasted like 20 minutes of my day looking at XKCD comics afterwards. In this comic, the main character discovers Python and just how simple everything truly is. Not everything is all peachy in the Python world, however, because this XKCD was, I think, from like 2013. There's another, or 2007, there's another XKCD from 2018 that has a more somber picture of Python, which I'm sure many of you have already encountered as you've tried to set up Python on your computer, which also is another fun problem to solve for most people. This is kind of what a typical build looks like for Python these days, unfortunately. Python also comes with some very Zen-like instructions. If we import this, we get to see the Zen of Python by the creator of it. And these are 19 sort of tenets of Python, which should always be followed. In summary, simple is always better. And as we code Python, we get to see all of these tenets in action. And I'll leave you guys to explore Python and find other jokes or hidden gems in it later. So, okay, that's the fun part out of the way. Let's get to solving some questions. So first things first, I want to ask, I asked you guys how your Python environment setups have been going. And I'm pleased to see that a lot of you guys have already set it up. Some people are getting errors. Some people haven't started yet. So make sure you get a chance to start setting that up soon, as you're going to need that soon for your projects. This is a good chance to ask me for some issues. I see already some people are confused about pip and it being a pain on Windows. So maybe we can use a few minutes to kind of help set some things straight, and hopefully some people who've already had a chance to set up Python can also help me out here. Oh boy, Michael, that is a painfully relatable situation to be in. Um, yeah, big gotchas in setting up Python is there's many ways to set it up, and none of them sort of work well together. So if you follow one tutorial and then follow another, you might end up with two different Python builds that don't work well, and sometimes it is a pain to kind of remove. Um, we could, if you guys have questions about Python and setup, definitely use your TLs as a resource, or use me as well. You can message me, and definitely post it here in the channel or in the help channel, and hopefully your fellow classmates who have had some better success can help you out. John, you asked, what are the main differences between Anaconda and Miniconda? I'm not sure. What is Python Anaconda? That sounds familiar now. Oh, right. So are you from the data stream, John? No, web. Okay. I'm not fully sure about Anaconda or Miniconda, to be honest. From quickly Googling it, it sounds kind of like uh, a platform for doing some data science. But maybe we can talk about that after if you're interested. But I'm not sure what that is. Okay, so we can move on past the questions about setup for now, and maybe if you guys can paste your questions here, and maybe we can get to them later. But I also want to, before we get started going over basic Python stuff, I want to give you a couple of resources, because as we're going to be learning a new language, another great thing that we get to start to learn is how to read documentation, and basically how to use the community, that a new community, and how to find resources to help us understand new syntax and new Python and new language sort of idioms. So here's a couple of links that I'd like to share. So first is the main website for Python, but it's a great resource to get yourself sort of started with downloading and setting it up. But it's also got a lot of great links to the official documents and also some other getting started tutorials. As you can see, Python does obviously keep that sort of humorous spirit. This library reference, keep this under your pillow. You're going to be referencing this for the rest of your life, pretty much. This is basically the entire Python standard library, and it's going to go over, it's going to basically have everything that you are ever going to need that comes with Python. So if you need to remember how to make a for loop, you can take a look here. If you need to remember how to reference or how to read a file, you can find that here. You can find pretty much everything here. There's also some great how-tos, and also the differences between different versions of Python. You might have noticed that Python has kind of two popular versions. There is Python 3, which is what we're learning, but there's also Python 2. And Python 2 was the most popular version of Python for an incredibly long time, Python 2.7. Now more people are starting to turn their apps into Python 3 versions, or write brand new code in Python 3, but it's not entirely the same language. It's basically the same, but they've modified some built-in functions to the point that the two languages don't fully work well together. But luckily there's not a huge ton of differences, and Python 3 has had some incredible new tech built into it. So we're lucky that we're kind of living in this age where there's a huge amount of development. It is exactly, yeah, it's like ES5 and ES6, exactly. Or maybe even more like old school, like even older than ES5 JavaScript. And then ES6. So we're actually going to take a look at some Python 3 stuff today that doesn't exist in Python 2 that is way nicer. Oh yeah, and thank you for sharing that, Wilfred. Yeah, so eventually Python 2.7 will be retired, and all of the people who still uh, like to hold on to Python 2 are probably going to be kind of upset, but luckily those people are few between, and we're all for progress. Cool. Some other resources that I linked in there is Learn Python. So this is a really cool resource as well that will basically go over a bunch of the basic sort of examples, which we're actually going to go over today, but you can then go and kind of learn and reinforce the lessons yourself. For example, loops, they even have code that you can run and it will eventually execute here in this shell, as we can see. So this is definitely an incredible resource for getting you up to speed with sort of the basic Python syntax and whatnot. And then you can also get into some advanced stuff on if you so please. And we also have a really awesome resource specifically for most of you, which is a cheat sheet from JavaScript to Python. So obviously everyone's coming from a very JavaScript heavy kind of headspace. So it's very great to kind of see the parallels between these two languages and how you would go ahead to and write the same sort of code in Python. So how you would do comments, for example, in JavaScript, we all know as 2 forward slashes. We'll add a comment. In Python, it's a number, hash, tag, whatever you want to call that. When you want to do prints, our console log turns into a print, and so many other examples. And we'll basically go over some of the syntax in a little bit, but this is definitely a great sort of cheat sheet to use kind of early on. I know I personally, when I've been coding in JavaScript for a long time, I accidentally throw in brackets and stuff like that into my code in Python, and everything ends up breaking. Let's see, and yeah, there's also a link to the project that for this week, which we'll go over at the end of the class. Cool. So this is the documentation. You're pretty much going to probably be referencing it all the time. What are some other ways that we could go about learning a new language? Or when you guys are learning, what are some resources that you personally like to use? YouTube. Yeah, amazing. Guessing is fantastic as well. Yeah, trying to build something. I think guessing and trying to build something is kind of similar. You basically have a goal in mind and you basically just keep at it until something works, right? 20 Stack Overflow questions later, and you might have answers. Yeah, for sure. I think what's also great about the purpose of this computer science curriculum is to also kind of get us a couple of mental tools, mental models about problem solving as well, that we could pretty much attribute both to programming and debugging and figuring out how to solve problems, which I think is going to be really awesome. Yeah, actually porting a program function to a new language, Wilfred, that's a great example. So you guys have written probably a lot of different code in JavaScript. A great practice is to try to write the same code with the same results in Python, and that way you can master the kind of the syntax and the idioms of a language much quicker. That's definitely a great idea. Cool. Okay, so those are definitely all fantastic suggestions. So let's actually go into coding. So for today's class, we're going to go over basically go over some basic syntax, some basic functions, and end with with talking about the project and hopefully get you guys be able to complete at least the first part of it. So like every great start to any CS or language tutorial, we always want to start with printing something out and specifically printing out hello world. What's awesome about Python is this comment right here, print hello world. You could pretty much get rid of this comment and run this code, and it basically is already done. Print is your console log. Print is going to be your friend for printing everything out to console log or to a standard output. Sadly, this would have been true in Python 2, but in Python 3, print is now no longer this sort of strange reserved word. It's actually a function, and we have to call it like a function. So now, if we go ahead and run this code, we have successfully printed hello world, and our journey has begun. Declaring a variable, we're obviously going to need to do a lot of that. And variables, unlike JavaScript, don't need a prefix or a type at the beginning. So in JavaScript, we would have done var or let or const. In Python, you just have to name the variable whatever you want. So let's name a variable name. And we have now created a variable. We can also reassign it afterwards the same way. We don't need to add anything at the beginning like let or const or anything like that. There are some great things about this in terms of it's easy, but there are also some drawbacks because you can't actually create a const in Python. So the Python community actually has some guidelines for how you want to go ahead and name your variables to sort of indicate if this is kind of a constant or a local variable or what is it. So very often you might see a all caps variable, and that generally indicates don't rewrite this. This is a constant variable. There's also another special thing that we could do in Python that, again, is purely just a syntax-based or a culture sort of based thing. These technically have no difference. But you can also start your variable with an underscore, and that kind of makes it a private name. So, or generally you would do this in classes where you would have private variables, but that's kind of how variables work in Python. They technically don't need to be defined as, they don't need to be defined with any sort of special type to them. Yazira, you asked, how does variable scoping work in Python? Great question. Variable scoping works exactly the same as it would in JavaScript, which is to say that if you declare the place you declare the variable, the scope, the variable will only live within that scope. So when we start looking at functions or for loops or other things like that, you will notice when we declare a variable within there, the variable will only live within that scope. But that does mean that if you create a variable outside of the scope, and there is a child scope there. So here we've created a name and it's in the, it's within the file scope. Any functions we created here, we can use the variable name. So it's very similar to JavaScript. And we'll definitely talk about variable scoping when we go more into talking about functions. Cool. So if we go ahead and print name as like this, we can see that we have outputted Austin out here. Sweet. So let's talk about string concatenation. So we can do quite a bit of things with strings in Python, and this is going to look quite similar to what we could do with strings in JavaScript as well. So let's say we want to print hello Austin or hello name. What we could do is we could do hello and just simply plus name. And the plus operator works on strings, and it will behave in a very expected way. It will go ahead and add Austin over there to the entire string. So when you're debugging, it might be very useful to print where you are in the code or something like that in variables. And in general, this is how we can concatenate strings. But any string literal like syntax in Python? Ronnie, you're asking. Remind me what you mean by string literal. Yes, perfect. So template strings is I guess what I would call, yeah, string literal, you're right, that is what it's called in JavaScript. In kind of a more basic way, you can call them template strings. Very glad you asked, because that's exactly the next thing that I want to show. So in Python 3, we have something called f strings or format strings. Yeah, that's right. We could use the old school percent sign. Actually, maybe it's not a bad idea to demo that out. It's kind of we could try it. I didn't have it in my notes, so I'm going to have to go through the very painful process of basically using the C-style strings that Christian is referencing. But let me show format strings first, and maybe we can talk about these percent sign strings. They're not bad to show off. They're just, well, the syntax is just painful. But let's check this out. So we can now, in Python 3, use these template strings, template literals, if you want to call them, what did Ronnie call them? If you want to call them string literals, we definitely have something like that. And to start it off, you just type in F and two commas, and we can go ahead and just reference variables with open curly braces. So this is very equivalent to how you would do template strings in JavaScript. Awesome. So this is actually something that was added pretty recently to Python and is kind of a much needed improvement. Maybe if we have a little bit of time, or maybe tomorrow in the demo, we could talk about what some other ways we could do templated strings. But I think that the best way to go about it is to use f strings. And so we could do other variables. We could execute code in the brackets itself, whatever we would like. Basically the exact same as how you would do it in JavaScript. And so all you have to do is append this f before you write your string. Cool. So that's strings in a nutshell. Let's talk about lists. And a list in Python is exactly the same as what an array is in JavaScript. And we create it with the exact same syntax with these two open brackets. So let's create some numbers. And if we want to go ahead and print that, we'll see that it goes ahead and prints an array, much like we expect. There's a couple other cool things we could do with lists. We could do something like this. List of zeros. And we could do something like this times 10. And let's take a look at what that will do. So that will create us an array of zeros, specifically 10 of them. So if you ever need to create a quick list, you can use this syntax. And that's kind of where a lot of people either fall in love with Python or kind of get a little frustrated because it doesn't fully seem like this should be allowed in a language. But this is kind of some of the beauty of Python, is that a lot of things that you might almost voice naturally. Hey, I want a list of 10 things. You can even make them empty if you want. For example, I just want a list of 10 things that I will then use later. I just want it to be size 10. So all you got to do is just multiply it by 10 and it works. So as you learn Python, you will discover a lot of these different sort of quirks of the language. Levy, you asked, when would you use format string method versus f string? Are you referring to dot format on a string? Yeah. So I guess, honestly, I would say use f strings if you can. The dot format, essentially we could do, do this kind of syntax. This is basically the syntax that Christian was referring to, basically. You could do this %d, or I don't even remember format off the top of my head. I apologize. I wasn't planning on covering it. But essentially, f strings replaces format. And in my opinion, it's a lot nicer. And I would just say always use f strings if you're in the Python 3 world. You would use format if you're not in the Python 3 world, or you have some older version of Python 3 that doesn't have f strings in it yet. Maybe we could skip talking about this for now, and tomorrow in instructor hour, we can go over format strings if we're interested, if that's okay with you. Oh, okay, yeah. If it's covered in the project, we could definitely go over it tomorrow. So, Justin, great question. What's my favorite standard library module? Whew, I had to think about that one for a bit. There's a lot of great built-in Python libraries. In fact, I kind of, what I love about Python is so much of it is so much of Python comes with so much power is already built in, unlike JavaScript where you have to download a lot of different node modules. Probably like the standard system libraries that you could use in Python that are very surprising. You can start computer processes and whatnot in Python. I think that's super cool. So Rain, you asked, when creating a list by multiplying like that, can you do something like incrementing the number? You know what? You could, and I'm going to show something like that in a sec. There's actually a better way than specifically this syntax for that, I think. But you know what? Maybe there might be a way. But we're about to take a look at something super Pythonic, super cool with lists, where we could basically generate lists in such a way. Oh yeah. That's true. You could also just use the range function, what John said, which will basically automatically generate you a list from 0 to whatever number you want. So yeah, thank you for that suggestion, John. Okay, let's take a look at how we would want to add elements to Q. Let's name this Q. So much like in JavaScript, we could go ahead and let me actually get rid of this for now. Much like in JavaScript, we have some built-in functions on arrays. And in Python, to add something to the end of an array, you would do q.append and some new item. So if we go ahead and print q afterwards, we can take a look that at first it was just 4, and now it's 5 unique numbers. This is something that basically I would highly recommend consulting the the docs in Python and find out the different functions that you have at your disposal for arrays. And there are obviously a lot of different built-in functions that arrays have. Cool. So let's take a look. Oh, Justin, you asked, what is the difference between range and xrange? I actually almost think that xrange is gone from Python 3. Let me see. I think I saw this recently. Actually, yeah, I have this highlighted. What is range versus xrange? I guess there is a difference, but oops. But yeah, in Python 3, there is no xrange. So it used to kind of work a little bit differently, but they decided that everyone was confused about it. Why bother? Let's just have range and xrange be the exact same thing because everyone just uses it. So in a way, John is kind of right. The only difference is it has an X in its name, and it won't work in Python 3. Yeah, exactly. Cool. So let's take a look at for loops now. So here is where things get a little bit different because we're going to start to notice some very unique things about the syntax of Python that definitely does not exist in JavaScript. Whereas everything else that isn't too crazy, a for loop is going to really indicate the difference between the two languages. So if we want to print all the values in Q, for example, here's how we could do that. We can say for element in Q, print element. And the first thing to notice is the syntax here. So first of all, you don't have to put this part of the for loop in brackets. And there's also no curly braces. And I think that is probably the thing that is the most confusing at first glance. But the way we scope different sort of parts of the code and how we scope some code into a different scope is with tabbing. So my Python and most Python is set up to either have 4 spaces or a tab, but essentially every scope will, every line will have to be on the same sort of indentation, and then it will run in the same scope. So if I were to print, we are in a for loop here, this code will print, oh right, I'm forgetting what I already discussed, which is we need to write print as a function. So let's take a look at our output. We printed 10, we're in a for loop, 60, we're in a for loop, 20, 5, 77. And as you can see, it reads almost like English, pretty much. For element in Q, prints that element. You can call this whatever you want. This is just the element. For E, for val, it doesn't really matter what we call this part. This is we just define a variable, and this variable is scoped to this indentation. So we can't just do print element here. That won't make sense because element is not defined there. And if I were to, let's say, mess up and put 5 spaces here, this all of a sudden is on a different scope. And in fact, my VS Code is already saying that it's an unexpected indent. But if we run this, we shall get a very expected error in this case, where we have it unexpectedly indented. And that is because there's nothing about, we're not entering a new scope here. That'll be like almost writing 2 squiggly brackets inside a function in JavaScript and hoping that works. There's nothing that says why we are entering a new scope, essentially. So it can get very frustrating sometimes when the error you have is a unexpected indent, but luckily most of our tooling by this point has gotten to a point where it's pretty easy to catch those errors before they happen. Cool. And if I were to write a for loop within here, if I were to do something like for I in range element, print I. Now this is going to be, keep doing that. This is going to be quite a lot of output, because what we're saying is take the element and then also create a new array with range. So if the number is 10, create 0 to 10 and print 0 to 10 out. But essentially, this is how you would nest scope, and you would keep doing that. You would always have a very consistent four spaces. If I did 3 spaces, I think that shouldn't work. It actually does, but if I were to do 4 spaces afterwards, it won't. So whatever the first amount of spaces or tabs or whatever at the beginning of the scope essentially defines how much spacing is going to define all the lines of that scope, all of the calls. But it's best to ensure that your IDE is always setting the scopes consistently, and usually 4 tabs is sort of the accepted guideline for scopes. I could have a vertical space. I could put out as many vertical spaces as I want. So as you can see, that worked as well. Yeah, so Levy, you're asking, are 4 spaces just a convention required? Yeah, so it is essentially a convention, and there have been many humorous debates over tabs or spaces in the past. I think the winning formula is to use 4 spaces, mostly because many computers will draw a space with just 1 character kind of difference, but tabs could be 4 spaces on one computer, 8 spaces on another computer. It depends on how each computer interprets tabbing, or like each operating system interprets them. So you might love tabs in your system, and then someone will yell at you because their code looks super stretched out. A great thing to do is to basically ensure that your editor, every time you press tab, will just create 4 spaces. So as you can see right there, I just press tab, and as I click my arrow key left, it traverses each individual space. It's not a tab character. So I would highly recommend doing that. I'm team spaces, but I'm not team pressing space 4 times. We want to make our lives easier. Okay. I'm just thinking if right now is a good time for a break in between before we get into list comprehensions. We've been going for about 45 minutes. You know what? Let's take a quick break, and the last 45 minutes, we will go over a couple of really cool, very Python-esque features of the language. So I'll give you guys a 10-minute break. And I'll display this. I'll be back probably sooner if people have any questions in the meantime, and we could just chat about different questions for now. So here, I'll put this here, and I'll put this Slack over here. Okay, so I'll see you guys in about 9.5 minutes. Oh, you're right. We do need elevator music for this break. It's a very good idea. I'll make sure to find. I already have a great playlist in mind now that I think about it. Um, so what am what I'm gonna hang out for 7 minutes here while we're on break. If anyone has any questions, in case anyone's wondering why I prefer spaces as well, is because the first job I ever had, this internship, the first internship, I got yelled at by my manager very quickly for having tabs as the default setting for my editor because it broke all of his, it didn't work on his computer because he loved using this like super specific operating system with Vim as his like kind of code editor. And I've been using Spaces ever since. But I think that is a very reasonable stance personally. So yeah, what's life without a little getting yelled at by your boss, right? So everyone's got to learn the hard way sometimes. Wonder if my computer just plays music. Is that going to go over on? Is that working? It's not. That's not how it works. I have some great lobby music. Oh, interesting. I haven't had this set up before. Oh, okay, here it is. Oh, really? Whoa. Okay. Is the music quieter now? is is oh, okay, sweet. Okay, great. I think every developer has a moment where they discover something like vaporwave and find their perfect programming playlist. It's like just barely there. Michael, I like that suggestion. Maybe we should just start having vaporwave behind everything. You know, I don't play any instruments. I'm terrible at music, unfortunately. Every time I pick up an instrument, I put in like 30 minutes of trying to like do some chord progressions on a guitar, and then unfortunately my patience runs out. All right, cool. So the time is done. Maybe I'll start putting my some music in the back of my instructional hours, and we can see how we feel about that first. Cool. All right. Yeah, we could try that out, that format. Um, cool. Okay, so everyone can hear me fine now that I've turned off the music. Okay, great. Um, okay, so uh, let's just quickly get back into this. So we have talked about Python, taking a look at how to do some standard output with print, declaring variables and using them in standard output, in string concatenation. We've taken a look at a few basic things with arrays and how to print them. Now let's take a look at something that is a bit more unique to Python, and it's a concept called list comprehension. So as we recall, the word list, it's just the same as array in JavaScript. But list comprehensions, it's essentially a way that we could build lists using functions, kind of. We could take a look at how we could do that. So for example, let's start with an array of just 1, 2, 3, 4, and 5. And now we have this task: create a new list containing the squares of all values in numbers. How would we do that using like a for loop, for example, pseudocode it, if anyone could throw out some pseudocode? I think it shouldn't be too difficult for them for the most part to basically just, we might do something like, yeah, we might just basically loop over each number in numbers, take each number and just n times n, add to new list. That's basically how we might do something like that. Maybe we can indent these to be more Pythonic. But there's actually a one line solution for this that essentially does all three of these steps. And we can accomplish this using something called list comprehensions. So let's take a look at this. Let's define a new array. And instead of just creating it and then writing a for loop, we can actually write some code inside the array itself. And what we could do is we could essentially write all of the for loop right on line 32. So the function to multiply to get a square of a number is just num times num. But what is num? We have to define that. So for num, okay, but what is num referring to in numbers? And that, if we want to print numbers, and then also print squares, we can see what will happen. So there we go. There is the original numbers array, and there is a brand new array squares with all of the numbers multiplied by each other squared. And let's just quickly take a look at this syntax. So this is the pseudocode for a for loop, and in here every line is indicated. So this is the actual operation that we want to do in the for loop. Right now, this is just a function written like this. Eventually, we can talk about writing even more complicated functions, or in JavaScript, when we pass functions as references to other functions, say in callbacks, we can essentially kind of do that here as well. So num times num will multiply the variable num in another array. Can I use, let's see. I think there might be, yeah, I could. So that's another solution for squaring numbers. I could also do num plus one, do pretty much anything. I could do string comprehension here as well. So I could do f number is num, and obviously squares is a terrible variable name now, but it will create 5 strings with number is 1, number is 2, et cetera, et cetera, et cetera. Cool. And this is a very, I think, powerful and very cool concept of Python that definitely takes a little bit to master, because maybe it's not super obvious what we can always get away with here. But this is the gist of creating a new list of numbers. So usually you would have some sort of for loop for a variable in some other array or a list, and then you would just have to define some kind of function. In other places, you could use map, for example, in JavaScript. It's kind of similar to essentially using maps in JavaScript. We can also add conditions to list comprehensions. So list comprehensions don't have to, a list created through a list comprehension doesn't have to actually be the same size as numbers. So let's take a look at this line right here. Create a new list containing only the even values of numbers. So let's create evens. And again, instead of just going through a for loop and say maybe writing an if statement, if this number is divisible by 2 and the remainder is 0 or something like that, we could just do that all in the same line. So basically, what we're going to do is we're going to return number for num in numbers. Now, obviously, without this, what will the array look like? Or just right now, actually. Sorry, I didn't mean to say without this. I meant as of this moment. Yeah, it'll look exactly the same because there's nothing saying what should be added and what should not be added. There's no condition. So the way we can add conditions here is we can add them right after this for loop. So num for num in numbers, if num divisible by 2 is 0. This operator is the modulo operator. It will return us the remainder of number divided by this number, in this case 2. So if the remainder is 0, we know the number is divisible by 2 and is thus even. So essentially, do this, whatever is here. So in our case, it's just return that value for the num and numbers if this condition is true. And this condition can always be true. So if I did just if true, capital T, then it'll still be a copy. If I did if false, then we might predict that it'll be an empty array because no condition passes. But in our case, if num %2 equals 0, and we print evens, we'll notice that only 2 and 4 make it past this filter. Jasmine, doesn't Python return the remainder when you use divide 2? I think possibly. I mean, I think maybe you have to do double. No, I don't think so. I think it's just a division. If we did 10 divided by 3, we just get a number back. But 10 mod 2 is 0. 10 mod 3 is 1. So there definitely is a keyboard shortcut, or there might be. I don't have it set. I just press run Python file in terminal right here. So let me close. Let me just close this. And when I press run Python file in terminal, it runs down here. But all it does is actually just find my version of Python 3, and then just find where this file is, and just run it. So really, I could just press up again to just rerun it. Oh yeah, and play. Oh yeah, cool. Play also runs it. Awesome. I'm actually not super familiar with VS Code. So these are great tips for me as well. Sweet. Okay, cool. So this is the power of list comprehensions. There's definitely a lot that you could do with it. But essentially, once you're able to traverse some sort of array and execute some sort of function, and then even add a conditional to it, you could do a whole lot with that. Let's take a look at another example. So let me add this on 2 lines because this is a long comment. Create a new list containing only the names that start with S so that they are properly capitalized. So it's not only that we want all of the names that start with S, but we also want to give them their proper pronoun treatment and capitalize the first letter. Anyone want to take a stab in the comments on how to do this one with list comprehensions? We'll call this S names. Yeah, we could definitely use regex. So we could use that. There's actually even easier ways to find out if the first character is an S. And yeah, cool. So John is suggesting we use capitalize, or Adam actually got to it first. Awesome. So name string.capitalize does exactly what we expect. Any string we can just type in capitalize and it will run and capitalize the first letter. So definitely that. Probably a good variable name for the variable is probably name. So let's go with name.capitalize for name in names. And yeah, and Reed's got another good suggestion. We actually don't need to do 1:. We only care about the first letter. And just like in JavaScript, strings can be accessed in the same way as arrays with the square bracket notation, as Adam is suggesting in there, and as Rita suggested as well. So we could do if name at 0 equals s. There's going to be one problem with this, if anyone sees it already. Yeah, John. John says case. John, what do you mean by case? If you could elaborate a little bit more. And Wilfred, you're hitting on kind of like I mean, is capital S going to work for us too? Is that going to get all of the names that we want? Yeah, so we want to do S or S, right? Wow, that sounds silly when I say it out loud. S or capital S, like Ronnie suggested. And one cool thing we could do is we just do dot lower. So whatever is the character here, just lowercase it and compare it to S. We could do an or, if this or that, we could do that. But we could also just go ahead and call a very handy function that exists on all strings, is just to lower it. And as we go through Python, as we learn more and more and read more of the docs, we get to discover more of these functions. So essentially what I asked is, how can we maybe lowercase a word in Python? And if we just type in that in Google, in Python, we already get Geeks for Geeks answer right there in Google. And I'm sure that the third, I knew that the third thing would be a Stack Overflow, and I'm sure that it's exactly what we need. Awesome. Cool. So let's take a look at our work and make sure that it works correctly. And it does. We've got both Sarah, Sam, Sandy, and Sean, and they are all properly capitalized, all done on one line in a very handy way using list comprehensions. In your project, you're going to use list comprehensions and have a chance to kind of learn about some even more cool features about that. Cool. So finally, let's move on to dictionaries. And dictionaries go by a very dear word for us in JavaScript. They are exactly the same as objects, the data structure that essentially all of JavaScript is built on. And to no one's shocking surprise, the way we define a dictionary is exactly the same way as in JavaScript when we define an object, just to open, close squiggly brackets. And much like in JavaScript, we actually interact with dictionaries the exact same way. So let's create a more interesting dictionary with a couple of key and value pairs. So let's say D equals apple, and that is fruit. And let's say cucumber, and that is a vegetable. So if we ever need to know everything there is to know about apples or cucumbers, we have this very handy dictionary already made for us. And the way we would access values is, again, very unsurprisingly, with square brackets and a string. And so if we print the apple, we would see that it is a fruit. Now, this is unfortunately the only way we can access variables or values in dictionaries, whereas in JavaScript you might be able to do d.apple, but in Python we always have to provide a string. But then again, if I had something like fruit equals apple, I can go ahead and put the fruit, and it will still go ahead and work, which is very handy. There are also some cool built-in functions for dictionaries. For example, print d.keys will print an array of apple and cucumber. It actually returns a data type called dict keys, but it essentially works the same as an array. You can also do d.values, and it'll do the same thing. And we can even iterate through dictionaries, which we'll get to in a sec, using these d.keys, d.values. Anthony, you're asked, how would you access, interchange something in a list of dictionaries? Well, let's try that out. Alphabet. Let's say we're gonna have like a children's book alphabet. Someone give me a word that starts on A. And B, anchor, bat, and one more for C, dragon. Thank you, Justin. I'm just kidding. Cool. I know my language. I know my letters. So if we have a list of dictionaries, we could write it exactly like this. And once again, it's pretty similar to what you might expect in other languages. And if we wanted to access, I hope this is, Anthony, I hope this is what you're asking, but if we wanted to access any of these individual dictionaries, we just access them like alphabet at 0, and then we could access A, for example, and then that would print us anchor. So we first have to get access to a dictionary, and then we just use it like any other variable, kind of the same way. We can also print dictionaries, and when you print dictionaries, it'll print them in a pretty format. And there's also, if you ever go ahead and want to print in more pretty ways, there are some pretty print libraries out there that will print dictionaries nested. We can also nest dictionaries, or we can put any kind of object we want here. So we can have anchor, anchorman. We can have all kinds of different words, for example, in this case. So you, just like any other languages, you could just go ahead and very naturally create dictionaries within dictionaries and traverse them in exactly the same ways that you would traverse them in other languages. So we've just done this part, access and print an element in the dictionary. And like I said, we could also go ahead and print the keys and values. And that's very useful for us when we want to iterate through a dictionary. So if we ever want to find all of the elements in a dictionary, or maybe modify them. Also, it's someone asked changing values, for example. You could just go ahead and do d.apple equals is the best fruit, for example, if you're so bold to say that. And then when you print D, you print D here. First, apple is a fruit, and then apple will be the best fruit. And yeah, Justin, definitely. So lists are arrays, and dictionaries are objects. And what's great is that in several weeks, we get to learn how all of those work under the hood. And we get to realize that all of these data structures are really basically fundamentally the same concepts in every language. And then we become incredible programmers that can basically just hop into any language and start using it right away. But yes, lists and dictionaries. Lists are arrays, dictionaries are objects. Cool. So let's finish off real quick with iterating through the dictionary. So let's first take a look at a very handy function that dictionaries all have. Print d.items. Let's see what that gives us. So we have a lot of standard output here now, so I apologize, but this is the line we're looking at. Dict items, and it's an array where the values are essentially this set where the first value is the key, the second is the value, again, key, value. And this is going to help us a lot when we want to basically traverse in an iterative way through a dictionary. So now what we could do is we could do for key value in d.items. We could print, and maybe we can do some kind of fancy format string. We could print key, key, and I have 0 creativity, value. And essentially this will print in line by line, apple is the best fruit, cucumber is a vegetable. So because d.items returns us this array, or really in Python what we call is an iterator. So it's not really an array necessarily, it's something called dict items, but we are able to iterate, as in we're able to use this syntax for something in d.items. We could have done, instead of for key value in d.items, we could have done for, let's say, pair. And so if we were to print pair, we could see what that looks like. Just to compare, here we have basically broken up the pair into 2 variables, key and value, right away. In the second loop, we did not do that, and so we got those 2 individual sets. So we can actually do pair at 0 plus pair at 1. And as you can see with my super lazy example, without putting any spaces in between, we have now extracted those 2 values. But essentially, we could skip this part by just writing for key and value in here. Isira, will items be ordered? What do you think, actually, right away? Do you guys think that the items will be ordered in a object? Yeah, John is right, and is right as well. They are not. They might seem like they are, but dictionaries make no promises about order. And if we care about order, that's a perfect time to use something like a list. But a dictionary's main purpose is to give you, is to allow you to look something up given some kind of key very quickly, but it was never designed to keep order. Most of the time, if I keep rerunning this, I'm gonna get the same order. And I'm sure that there is some basic order set up, but we should never rely on d.items to maintain an order. It's really just when we need to traverse all of it. Maybe we need to create a new object or something like that. There could be a lot of reasons that I can't think of off the top of my head for why you might want to iterate over an array. Maybe you have a dictionary, but an array makes more sense. And when we talk about more other concepts like time complexity and performance, maybe an array is a better object or a better data structure to use. And so d.items is a great way to convert one to the other in a way. And John, you're asking, are they tuples? Yeah, those two, the key value pair is a tuple. I didn't want to say it yet because I was going to introduce tuples later, and I didn't want to confuse anyone. But a tuple is essentially a immutable set of items. Anyone know other? The two things I just showed, lists and dictionaries, in Python, we call them collections. And there are a lot of other collections available in Python. Does anyone have any other examples of collections? John actually already suggested one, which was a tuple. Yeah, sets, for sure. So let's quickly take a look at a set example. I think we have enough time to maybe quickly take a look at tuples as well. So in Python, a set, and much like in JavaScript, you might define JavaScript a set using the set kind of notation like that. In Python, it's even simpler. Again, I keep thinking of fruit or just food as examples. But if anyone has a better suggestion, so let's say fruits, we could say apple, banana, cherry. And if we print it, we'll get all of this back. Yeah, fruits are animals, really. Those are just classic. Actually, don't even know, is cherry a fruit? Oh, that is a question for another time. So here's what printing a set will look like. And can anyone tell me what is kind of the special property of sets? Yeah, no duplicate, definitely. So if we were to then use the very handy fruits.add method, let's add, I think tomato is a fruit, right? Tomato, but then we want to add apple again. We should not see two apples in here. And we have successfully not seen two apples. Let's take a look at this order too. This is pretty weird. We wrote apple, banana, cherry, and tomato for some reason got added to the front. And that's because sets are unordered. Exactly. Sets don't care what order they're in. In fact, if I keep doing it, this is a great example. Set will not keep order. Now it's banana in the front, banana still, apple got second place now when tomato was in the second place. It'll never guarantee order. But what it'll be great at is we could write things like this: print banana in fruits, and the output will be true. So this is a great use of sets, is to detect whether or not something exists in a set. You would just pretty much use this built-in operator. And I mean, does it get any better than this? It's like almost English in some ways. Cool. And if we want to take a look at tuples real quick. So once again, let's look at just fruits. Let's use a tuple as an example: apple, banana, cherry. And let's print fruits one more time. Maybe I shouldn't use fruits. Maybe I should use animals this time. Let's say dog, cat, moose, beaver, representing Canada right now. If we want to print animals, we will see this tuple, and if we keep printing it, will order be guaranteed? Anyone able to answer that? Yeah, everyone who said yes is correct. Tuples are actually guaranteed to keep order. And that's actually really good, because if we think about what we did here in printing d.items, if these tuples, if sometimes the value could be the key or key could be that value, we could not do this line. So tuples are definitely guaranteed to keep order. So we could do this print animals at 0, and we'll always guarantee to have dog. But yeah, you guys already knew my second question. What's the special thing about tuples? They're not mutable. There is no way to add or modify a tuple once it's created. So it's a great way to define constants. In some ways, it's great to use them in something like it's why d.items returns a tuple, so that you can't exactly modify or kind of mess with this output. It's not the way Python wants you to update its dictionary, so I decided to use a tuple in that case. And there could be lots of different use cases. So let's try to modify animals at 0, and let's say lion, and let's print animals again. In fact, my VS Code is already saying animals does not support item assignment. So I bet if I run this, I actually get an error in Python. Tuple object does not support item assignment. Yeah, tuple should be iterable. Good question. So let's do for animal in animals, print animal. And there we go. Actually, a set is iterable as well. I hope. Yeah. So a set is actually iterable as well. It's just that order and being iterable doesn't exactly matter. Tuples are faster. Tuples are faster than what, Anne? Than lists. It could be. I'm not sure necessarily that that's something that tuples are kind of promised or made for. Tuples are really more focused on being immutable. So they might be a little faster, but in general, when we'll talk about a kind of time of different objects, and we might notice that tuples and lists actually behave kind of similarly. It's really just this promise of it being immutable is really the biggest kind of value add of tuples. So when you need a ordered mutable collection, you would use a list. And if you need a ordered immutable collection, tuple is your go-to. Cool. Oh, one more thing about tuples, actually, as I'm kind of reading some docs, this is a pretty cool little thing to know. If you want to create a tuple with just one element, there's a bit of a gotcha. So let's say single tuple, and let's say the value is just 1. If you print the type of it, so there's a built-in function in Python called type, very similar to type of in JavaScript. you might not get what you expect. So we expect it to be a tuple, but if we run it, we actually get a string. So print single tuple, actually not going to be a tuple, it's just one down here. So to fix that, so let's call this single tuple string. To make it truly a single tuple, all you have to do is add a comma afterwards. And then when we print single tuple, we'll print its type. Let's take a look at what that is. The tuple will be a tuple, and it in fact will be a tuple of size 1. So if we did len single tuple, we'll see that the length is 1. It definitely is. Like that definitely personally bothers me, seeing kind of a dangling comma like that. But unfortunately, that is what we have to do if we want to create a single tuple. Oh well, we can't unfortunately live in a completely perfect world, even if it's Python. Yeah, I can't really think of too many cases where I use a single tuple. Why is it called a tuple? That's a great question. Let's see. Well, we have a whole Wikipedia article that we can read about this. Basically, who knows? Etymology. Oh my goodness. There's a whole thing. Dustin, that is a not sure if we want to go unpack that. There's clearly a whole lot to know with such a seemingly simple question. Yeah, when it's like a whole Wikipedia article and they already have an etymology, we're just gonna have to accept that it's called that because someone called it and people it's stuck. So yeah, I have no idea either. Steve, good question. The idea of unpacking and packing uh, collections, that is a question. Let's see. I'm actually going to search it up myself, to be honest, because I can't. Python unpacking list. Let's quickly take a look at the syntax here. Oh, okay. Oh, cool. You can read all about it here. Look at this. This is great. Oh, yeah. We're actually going to talk about this on Thursday. I forgot that we were going to already discuss this, but essentially, you could use the star operator to unpack a collection. So if we have animals up here, I can unpack it with this star, and we can see what that's going to look like. So this is a little confusing, but essentially I'm trying to figure out a word that's better than unpack, but it's like perfectly named. It basically takes every element and kind of extracts it from the list and essentially outputs it as a individual element. The reason why it printed this way is because the unpacked kind of set of items. That's a good question. The print knows how to handle this in an elegant way, basically. There isn't really much better of a reason why it printed with these spaces in between, for example. Yeah, okay, and here is actually a great example of what this unpacking does. It essentially takes all of the variables, or it takes all of the values, and basically just imagine if I wrote dog, cat, moose, beaver. Like it basically just it removes the tuple syntax, and it basically just shoves all of those elements as variables to wherever wherever the whatever place it got unpacked at. We could talk about that. Yeah, it's essentially like spreading state in so kind of the ES6 format of opening up some kind of array. It's essentially like that, but it's a little bit more powerful. And we'll actually talk about this at length on Thursday, because we're going to use this concept a lot when we pass arguments to functions. And so arguments unpacking is quite an important concept there. So that's the thing. It's not really a type. It's essentially it essentially kind of lets loose all of the variables. So if you pass them to type, it's like passing 4 variables into type instead when we do type unpacked on animals, because it's no longer just an object. It's 4 independent objects in the code. And you could do that with lists as well as tuples, so they could all be unpacked. I'm also loving all the questions, by the way. I really appreciate you guys being super active in the chat. This is great. So any more questions? This is where I wanted to end today's discussion about Python. Essentially, the goal for this week is a bit lighter than maybe some of the weeks to come. The goal of this week is to basically get you guys acquainted with Python, get you to understand some of the basic data structures and standard libraries that Python has to offer, and get everyone reading the Python docs, Googling questions, getting stuck, getting unstuck, and really getting down and dirty with a brand new language. So next on Thursday, we will talk about functions, classes, and some more standard libraries of Python. And the project for the week for everyone basically reflects this purpose of kind of learning all of the different basic concepts of Python, and we can go over that right now. John asked what VS Code extensions I'm using. I'm not using any. Actually, there's a stretch in your Python. Oh, okay. That's a bit of a lie. I'm personally using the Vim extension because I love it and I don't know how to code otherwise, but don't necessarily recommend it. But VS Code actually works incredibly well with Python out of the box. It actually works much better with Python than almost any other language. I pretty much had to do no setup. I just opened these files and they started working, I think. I can't remember if I had to set up anything for Python. It's possible that I can't remember. You might have to configure Python VS Code to find your Python, like where your Python like executable is, so that you could run it through VS Code and just kind of simplify your life. But honestly, I'd just oh, okay. Oh, you know what? Maybe, yeah. So if there's a Python extension, then yeah, you probably just have to do what VS Code is yelling at you to do. I wonder if there's a way for me to see what my extensions are here. We can take a look. So yeah, I got Vim, and okay, I do have Python. So I guess I didn't even realize I already had it. So yeah, just go ahead and make sure you have these two. Um, Maybe there's stuff that you might find that you find is an amazing quality of life improvement, and I would love to hear about those. So definitely share with me and your peers any kind of cool extensions that you've discovered. Yeah, VS Code isn't my kind of main editor. I actually use PyCharm for Python mostly, and there I have probably a few more extensions. Um, but uh, but I think VS Code is a lot better, especially the fact that it's free and it's great. Like you have to dish out quite a bit for PyCharm and the other IDEs. So VS Code has been really dominating sort of in popularity recently. Oh, if PyCharm is in the Lambda School package, that's pretty cool. Um, oh, that's really great. I personally really like the JetBrains um, offerings, but honestly, um, it's like a ongoing debate slash some might describe it flame war out there over what IDE is best. The best way to lose like an hour of productivity at a company is just in the general Slack channel, ask what IDE is best and just watch the chaos unfold. We recently had that at my work in the engineering channel. Basically lost like 2 hours of productivity because everyone was flaming each other for using the wrong editors. There's literally an XKCD comic about this. Okay. Uh, Now, let me quickly bring up the project and we could take a look at what we have to do for that. Yeah, it's XKCD. You know what, Jordan? Funny enough, there's an XKCD about discovering new things. It's it's like a joke that there's a relevant XKCD for everything. So welcome to the club of knowing all about XKCD. Yeah. Um, James, good question. Yeah, I'm going to clean this file up a bit, add some more comments, and I'll throw it into this channel after this. Okay, cool. We have a couple of minutes left. Let's quickly go over this the project. So it's called Intro to Python 1. So the kind of a nice gentle introduction to Python. You should be able to see these links in your um, training kit. But if not, I linked it in the sort of useful links section up there, but we've had quite a bit of discussion since then. So, you might scroll up and find it again, or I can just relink it again after class. So the first project is, again, fairly straightforward. Make sure that you have your environment set up. Uh, Definitely try to get pipenv or some kind of environment set up. You've probably used something like Node-N for maybe some kind of node environment manager for JavaScript before. It does a very similar sort of purpose where per project you could kind of scope down your Python sort of program and everything you have installed for that Python project, and that way uh, global installations of modules or things like that don't interfere with each other. So definitely a great thing to install. I think when I first started learning about Python, I didn't do this pipenv thing, and that's how my kind of world became the disaster that XKCD comic that I showed at the beginning sort of evolved into, because I have like some global Python library that's kind of clashing with something else that I have locally, and it could become a mess. So definitely worth going through the hassle. It's not, you might discover some issues, but definitely try your best to get the environment set up. Then basically there will be several files in source here. So we could take a look at something like hello. And all you have to do in this is print hello. So we've done that. You could basically take a look at exactly what we did for that. But then there will be a few things that you will have to kind of discover on your own. So comprehensions, there's going to be quite a few more things, and we've done quite a bit of this already, but some of this you might have to go and Google and kind of try to dig into the Python community to answer. There's a few things here that we have not covered yet. So like functions and arguments and scopes, things like that, we haven't really talked about yet. So if you want to go ahead and learn them before Thursday's lecture, by all means. Otherwise, don't feel pressure to kind of learn some of the stuff that we haven't covered yet. And if you have finished all of that, there's a couple of stretch goals, and you can take a look at adding a linter to your Python. So there's a standardized style guide called PEP8, and essentially it's kind of like ESLint. It tells you if you're coding in a Pythonic way. It's very good to just even know what the Pythonic way of coding is, but it's better to set up PEP8 and have your editor constantly yell at you for the rest of your life. And then there's also a couple of cool suggestions. I can't remember who, but someone suggested to rewrite your old code into Python. Amazing way to get what you already know into and transform it into what you're just learning, to kind of get the same concepts in a new mindset to learn the syntax. And then, yeah, why not try out one of the oldest algorithms known to humans and try to implement it? But those are stretches, so definitely not mandatory. And to kind of explain how the course is going to go, every week we have 2 guided projects. I'm sure that Alyssa or other people have already explained this, but tomorrow we're going to have we're going to have instructor hour. And typically that's essentially a Q&A for anyone here to come with any questions. And if we don't have any questions necessarily, I think I will either find some cool topics to talk about for us, or I will maybe help with the project, and maybe we can go over solving 1 or 2 of the project tasks together. Cool. So that is pretty much it for this lecture. Does anyone have any more questions about what we covered today? How was my day? It was great. It was great. I was trying to ramp up on Python and get myself ready for the class that I haven't taught in 5 months. So it's basically a lot of prep. So Adam, you asked how important is it to being able to use F strings? Yes, you do need at least Python 3.6. I would recommend being on Python 3.6 because the format strings are so much better than calling like dot format. But I mean, the other ways aren't necessarily terrible, and actually not a bad idea to kind of learn about other ways to do string formatting. Like I said, maybe if that's something that's interesting, we could talk about that in the instructor hour tomorrow. Oh, well, Ronnie, thank you. You guys definitely have me for the first half, and there's not really any reason not to have me for the entire lecture, or the entire course, at least right now. So we'll see. I'm hoping not to go anywhere soon, because I would love to teach you guys all of the awesome content that we've prepared. I mean, um, I love computer science, and definitely would can't wait to kind of get into some of the bare metal of programming concepts. Cool, awesome. Thank you guys so much. It was a pleasure, and I will see you guys tomorrow for instructor hour. And if you're not there, I will see you guys all on Thursday for a guided lecture. Good luck with the project, and I'll see you guys soon.